Hello everyone, my name is Nick, and today I will be talking about the use of continual learning as a tool to mitigate sample bias. This talk will follow a simple structure where I will first identify a problem that I have faced that motivates the use of continual learning. Next, I will define sample bias and continual learning and explain how it can be used in our motivational example. To finish, we will conclude with some final thoughts. Say you want to create an app that helps users identify objects as recyclable or not. In order to do so, you first need clean, labeled data. However, this is not as easy as it sounds. More so, your model may do exceedingly well when training, however fail when the user takes their own pictures, getting an incorrect prediction. One way to solve this issue is to look at the data we are training our model on. But first, let us quickly define sample bias. Sample bias occurs when the collected data doesn't accurately represent the environment the program is expected to run into. When training a recycling model on publicly available data, you can see how it may be difficult to find images that best represent how users may use your model. For example, we may train our model on this data available from a Stanford student's GitHub repository. However, we can notice that each image has a uniform background, and the general user of our model may not be taking the picture of their trash with this uniform background. More than likely, users could take a photo of their trash in their hand or with noise in the background. Therefore, we need our model to be able to accurately predict these images as well. This is where continual learning can benefit us. So what is continual learning? Let's first look at a rough outline of the machine learning's model's lifecycle. First, we have the data and we need to validate it. Once we validate it, we can create the model and deploy it. At this point, users can access our model through an app or a web app, and our model can start making predictions, and this is where continual learning takes place. We can monitor these predictions, and we can get new data from these predictions and add it back into our data set. In general, continual learning is the process of adding new data into our model after it has been deployed, usually to help your model perform a new task. In our case, we want our model, which was trained on images with a uniform background, to better perform with a hand in the image and noise in the background. Personally, in order to do so on my recycling web app, I created a feedback mechanism that allowed users to report an incorrect prediction. After I had amassed 500 new images of both correct and incorrect predictions, I validated the new data, added it to our original dataset, and retrained the model. This led to my use case accuracy increasing as our dataset better represented the environment our model was being used in. And you can imagine if we continue this cycle of every time we get 500 new images and we retrain our model on a larger dataset, we start approaching a dataset that represents the population. And this, in essence, will mitigate our sample bias that we mentioned previously. In this short presentation, we looked at an example of using continual learning to mitigate sample bias via the lens of a recycling web app. Note that as with every machine learning problem, the use of continual learning is relative to the problem it is trying to solve. There are instances where it is best to just use two separate models. For example, if my recycling app is being used in two different states with very different recycling guidelines, I'd want to make sure that there is a model being trained on each state so that we don't confuse any model with incorrect information. Thank you for listening.